Hi, this is test 2 on my AS level different tests that I'm going to share. Make sure that you follow as you get ready for um, taking on the course. Right, so this one is still on equations and expressions and inequalities as well as identities. The first one says the quadratic equation 2x squared minus 5x plus 8k squared equals to 0 has unequal roots. When you are told something has unequal roots, it therefore means the discriminant would be greater than 0. Okay. Find the set of possible values of k. So for using the discriminant, obviously, that might generate a mark. So the discriminant would be -5 all squared, or just 5 squared, because everything would be positive there, minus 4 times the value of e, which is 2, and our value of c is nothing but 8k squared. Okay, if you were to clean this up, the discriminant would be 25 minus 64k squared. Now, one more important thing to remember is that you are dealing here with an inequality. So the inequality would basically be 25 minus 64k squared would be greater than 0. So if you were to think of this in terms of a sketch, this would be a sketch where, let's see if I do that, and then maybe perhaps I can go back. So this is going to be a sketch where the parabola will have a maximum value. Alright, so that's because of this negative here in terms of looking at it through that way. So my solutions is greater than will be above the x-axis. Okay, and if the solution is above the x-axis, it means that the answers will be a given range. So what I need to do is I need to make this an equation, 25 minus 64k squared equals to 0, in order for me to find the critical values. And once you do that, you can then use those critical values and write that range down. So of course, this becomes, this is like the difference of two squares. So that's 5 minus 8k, and the other one would be 5 plus 8k equals to 0. When everything equals to 0, you say 5 minus 8k equals to naught, or 5 plus 8k equals to naught. Therefore, k would be, in this particular case, 5 over 8, or k would be, in this case, -5 over 8. So k will be positive and -5 over 8. So my answer, therefore, after now I've determined what my critical values are, so these are the critical values. They will be what you essentially write here, -5 over 8 and 5 over 8. But answers are above the x-axis, so that means k, and an inequality is less than, greater than 5 over 8, the big one, -5 over 8. Okay, so again, that's the range of values that will satisfy this particular scenario over here, possible values of k. All right, that brings me to the second one. Okay, so we've got some partial fractions here. So I think the only thing missing here in my typing perhaps is just to put that identity sign over there. Maybe we should take that away and change that to black, so it can be part of our, okay. Of course, I think we all get the idea. So here's the thing, once you now work with that, obviously I'm going to work with the numerators. So that means I'm going to say, okay, the ax plus b, should sort of be multiplied by x minus 1 minus c, which gets the x plus 3. Since the denominators are the same going to be, so I'm just going to let it equal to 5x squared minus 7x. Let's just have that x nicely. Now it looks like there's social distancing over there. Minus 7x minus 14. Okay, good. So let's just clean this up. This is going to be ax squared minus ax plus bx minus b minus cx minus 3c. Well, that will be identical to 5x squared minus 7x minus 14. Okay, so let's just have our x's together. Now ax squared is ax squared. So ax squared. Here I have plus. I'm just going to rewrite it as b plus a. The coefficients b plus a. So minus c. You just want to point that out. I have this b, which is positive, and negative here. And this one, of course, is negative, so I must also go ahead and change this one here. So that will be b minus a minus c. That will be the coefficients of x, of course. Then I have minus. Now here's the thing, I have got minus b minus 3c. Well, this could represent the constant term. Okay, the minus b minus 3c. Those ones, they can represent the constant term. Okay, minus 3c minus b just be numbers. Alright, that's identical to 5x squared minus 7x minus 14. So now we are going to equate the coefficients. And the way we equate the coefficients, obviously we can see that a is equal to 5 based on this scenario over here. This a equals to 5. And we also now know that b minus a minus c should equal to negative 7, which is what we have over there. But we do know what the value of a is. A is 5. So let me just go ahead and clear that out. So this is b minus c. Well, we take that over, that gives you negative 2. So that's another equation. And what else do we know? We also know, maybe I bring this in using a different color. We also know that minus b, or if you have to look at the constant ones, you have minus b minus 3c. Well, that equals to negative 14 that you have over there. Of course, once you're here, you can just go ahead. I can leave it like that. So I can take this equation if I wanted to, and this equation, and I can solve them simultaneously. All right, in order for me to find b and c. I already know what the value of a is. Okay, that means that b minus c, which equals negative 2, and you have minus b minus 3c, which equals to negative 14. You have got a positive and a negative, and when you have different sort of signs, well, you do nothing but add the two equations together. Okay, so I'm going to add this equation. You can either call it equation A or B or equation 1 or 2. Totally up to you. If you were to add these two equations, obviously that leaves you with the b's cancelling. Then you have negative c plus negative 3c, or plus negative 3c, that's negative 4c over here. You have a negative 2 going further to negative 14, that is negative 16. I think it's evident from this answer here that the value c will be positive 4. That is, if you were to substitute or to divide throughout by negative 4. So hence, if c is 4, then we can find the value of b by substituting that 4 into either one of the equations. And in this case, it will give me that the value of b would be a positive 2. Right, so my answers therefore are a equals to 5. So therefore, a equals to 5, b equals to 2, and C equals to 4. So these are the solutions that I was looking for. All right, so you can go ahead and write it down. Of course, there are many ways you can do this. This is just but one way of many, okay, in order for you to solve that. Question 3. So this one, again, you have the equation. You must find the equation of the cubic graph that is shown below. So you have got, it touches here, and the fact that it just touches there means that whatever that root is a repeated root, okay? So that means you have y equals a, then you have obviously x minus x sub 1, okay? You can say x sub 1, x minus x sub 2, but since this x sub 2 is repeating itself, I'm going to square that. I don't have to say x minus x sub 3 again, because it's repeating there. So if something touches there, the root repeats. That's what we have there. All right. So we also now have a point. We have a point. It's very important to know also we have a point, and the point we have is the point 0, 6, which we're going to substitute in for x and for y. So that now brings us to this. It brings me to, maybe first I'll write without a point, I'll say y equals to a, and then I have x minus negative 3, and this other one now here is something that is very important. Maybe I should also write this down. If the root 2 over 3 is not, very important that you should know this, it's not written here when I'm going to write it in the second part. It's not written as x minus, because that one is positive, 2 over 3. That's not what we're going to do, okay? But rather, we're going to write it as 3x minus 2 all square. Okay, very important that you should remember that, so that you don't have that problem. Okay, now remember, if you take that root and let it equal to 0, it's going to generate the same answer. 3x minus 2 equals to 0 is the same as that. Okay, so what I'm saying is x minus 2 over 3, if that is equal to 0, of course, it's very important that you notice first we're going to multiply by 3, that is 3x minus 2 equals to 0. That's what we're looking for. Multiply each by 3, and we want it in that form. That's what we want. It means the same thing. Okay, now that we have established that, so we're going to go back and we're going to complete the other part. Of course, that was in blue. So in here we're going to have x, but not x anymore. It's going to be 3x, rather. 3x minus 2. 3x minus 2 all squared. Of course, here you have y equals to a, x plus 3 is two negatives, generate a positive, and then 3x minus 2 all squared. So now we can go ahead and we can use that point here, that point which is 0, 6. So x is 0, and of course y is 6. So that's 6 equals to a, 0 plus 3, you have 3 times 0 minus 2 all squared. Okay, this is going to allow us to find the value of a. So 6 remains there, and this is 3. That's not a negative 2 all squared is 4. So this is 12. So that's 12a equals to 6. This means that a will be equal to a half. So actually now you can go ahead and write your equation. Okay, completing this part of the equation, you're going to say y equals to 1 over 2 x plus 3 and then 3x minus 2 all squared. Okay, just make sure that my handwriting gets there. So that's 3x minus 2. So this, in a nutshell, no need to multiply that answer, please. Just that is the final answer. That's all that we are requiring. Okay. Right. So that brings me to my fourth question. They say equation of a curve. The equation of a curve is so equation of a curve is y equals to x squared minus 6x plus k, where k is a constant. When they say find the set of values of k for which the whole of the curve lies above the x-axis, that means the graph does not intersect with the x-axis, obviously, and it's just another way of saying, this is just another way of saying that the graph has no real roots. And if that is the case, then the discriminant would be less than 0. That's very important. Okay, right. So what is our value of A? A is 1. Our value of B is -6. And our value of C, of course, it's K. So that means we have got -6 all squared minus 4 times 1 times C, which is K. This should be less than 0. So it's 36 minus 4K is less than 0. Now, of course, this can be solved because it's just basically going to be -4K is less than -36, dividing by -4, because you're going to now divide here by -4 and here by -4. That means the inequality sign switch and K would be greater than 9. Very important that the inequality sign reverses, and you also take note of that. Good. Now, there's a B part. It says, find the value of K for which the line is a tangent to the curve. Right, so what was the equation? It was y equals to x squared minus 6x plus k. Now, when something is a straight line is a tangent to the curve, that means that the discriminant is equal to 0. So basically, you want to take the curve and you're going to take the straight line, you're going to equate them, write it in the general form, and let that equal to 0, and we're going to calculate whatever the value of k is. Alright, and here it says value of k, which means it's just implying that you should just have one answer. If it was saying values, perhaps two answers. Okay, right, so here's value of k, so that means x squared minus 6x plus k. Of course, maybe very important that I also rewrite this. This is nothing but y equals to 7 minus 2x. Okay, so equals to 7 minus 2x. So of course that is x squared minus 6x plus 2x plus k minus 7 equals to naught. I hope you're following. So of course this is going to give us x squared minus 4x plus here k minus 7, obviously that's the constant, equals to 0. So now looking at the discriminant, that is -4 square minus 4 times 1, okay, times k minus 7, that should equal to naught, that is 16. You have minus 4k and plus 28 is equal to 0. The thing is 16 plus 28, that gives you 44. So you have got 44 minus 4k equals to 0. Minus 4k equals to -44. So therefore the value of k would be -44 divided by -4, k equals to 11. And that is the answer we're looking for. Okay. Right, so that's our solution to that question. Step by step, very important that you do understand what it means when something is a tangent to a curve in terms of the discriminant, and then you should be able to equate it to rewrite that equation in y equals mx plus c form, so that both of them are y equal to, then it's very easy for you to write it in the general form, and from there you take and solve the equation. So question 5, again another question that deals with identities. So again, there's more than one way of solving such an equation. So what we are looking for is the values of A and B and C. Of course, you can go ahead and multiply out the x plus A with that whole 2x squared business. So I'm just going to say, okay, the x will multiply with 2x squared minus 3x plus 4, and the positive A will also multiply by 2x squared minus 3x plus 4. Totally up to you how you prefer it. Okay, so I'll just say it's identical to that stuff on that side. Okay, so if I was to do this, well, I'm getting 2x cubed minus 3x squared plus 4x, and that gives me on the other side plus 2ax squared minus 3ax plus 4a. Okay, so let's see where we're at now. So yeah, the x squares, maybe I use the highlighter, that this and this goes together, and another, maybe if I bring in another color, the positive 4 and the minus 3a comes together, and the other one will just be a constant. So at the end of the day, I will have 2x cubed, then plus, I'm going to take the 2a minus 3, that will be for the x squared. Then I'm going to say plus, I'm going to have, very important that you do understand, I'm going to have the one for the x would be 4 minus 3a. That will be the one for the x. And then my constant will simply be plus 4a. So now I can go ahead and I can equate the coefficients. Alright, so I can go ahead and equate the coefficients. So that means there's nothing I can do with the 2 because it's not what I'm looking for. But this one here, the 2a minus 3, the 2a minus 3 should equal to b. What do we know? We also have the 4 minus 3a. This should equal to negative 2. What else do we know? We also know that 4a, the constant, equals to c. Right, so we can go ahead and we can actually work from here. But this one is very interesting because we have minus 3a here equals to negative 6. A will equal to 2. So if that is the case, I can come back here. Alright, so maybe I should just do that, and I should do that. So it's much easier. Right, so if A is equal to 2, that's 2 times 2, minus 3 equals to B, that's 4 minus 3, which is B is equal to 1. Then what do we know? We know that A equals to 2, so C will be 4, and then A equals to 2, so C is equal to 8. So my solutions, therefore, A equal to 2, B equal to 1, and C equals to 8. And these are my solutions. Okay. No need to panic. That is my final answer. Again, as I said, many ways you can do this, as long as you do your things step by step. All right, question 6. Now, I have a few ways of explaining question 6, and maybe also to finding that coordinate of A. And it could also be that that what I'm doing is a bit outside of your scope, but I think it's very interesting to know, of course, how to find that. Also take note that it's just a 2-mark question, right? So in order for me, I'll first do the traditional way that we expect you to do this. So you'll be saying, okay, if you want to find the coordinate of A, then f of x should equal to 0. That means you let the equation 2x squared plus 5x plus 2 equals to 0. And then obviously you go ahead and you do your factorization. And if you do your factorization, you should have 2x squared plus 2x, well, plus 3x. I think it's 2x squared, the equation, plus 5x. I'll come to this one now. I think it should be plus 3. So this equation, let's just correct our equation. Our equation should be plus 3. Okay, so that should be a 3. Just bear with me. Try to see how I can. See how I can. Okay, so that should be my equation. Just a little mistake from my side. Anyway, that is 2x outside, x plus 1, plus 3x outside, not 3x, but plus 3 outside, because 3 is a common factor. Then you have x plus 1, which equals to 0. So at the end of the day, 2x plus 3, or x plus 1 equals to 0. Well, I'm not really interested in this one, because this one I know the answer already. So I just want the 2x plus 3, which is equal to 0. And then I've solved in order for me to get what that value will be. So the value there will be x equals to negative 3 over 2. So the coordinate of A would be negative 3 over 2, comma 0. Okay, so that's how we normally would calculate that one. So towards the end of the video, towards the end, I will definitely show you two ways that you can find the value of A by doing something with the products, and also it will definitely be much easier for you. You can apply that also. No harm in that. Now they say determine the equation of the straight line through A and B. Now, if you know the coordinates of A, as we now know, the coordinates of A is negative 3 over 2 comma 0, and the coordinate of B, since that B is cutting the y-axis at 3, so it's 0 comma 3. Now, in order for us to find the equation, you obviously have to know your gradient. Now, it's straightforward. You don't need to use the other formula that they are giving you, all right, because it's with 2 marks. And you can also see that blue line is cutting the y-axis at 3. So you can already see that that equation will be y equals to mx plus 3. You can already see that. Okay, so the objective for us is simply, how do we calculate the gradient? The gradient, which you then can find by substituting any one of the points there. Now, let's say we substitute the point 0, 3, okay, then it's not going to help us much, because if x is 0 and y is 3, not really going to help us to find the value of m, is it? Not necessarily. Okay, let's suppose we calculate the gradient by saying, okay, the gradient would be delta y over delta x. We take two y values and subtract them, 3 minus 0. We take because I started with this b, so I'm going to say 0 minus, of course, that negative 3 over 2. If you were to do that, you'll see that the gradient will give you nothing but 2. So my equation therefore is y equals to 2x plus 3. Much easy to arrive and find the equation of that blue line in my diagram. What if someone was to say, and I just want to do this just as a matter of, you have the equation y equals mx plus 3. And let's say I take point A, where the y value is 0 and the x value is negative 3 over 2 plus 3. So let's suppose you want to find the gradient. So that's going to be negative 3 equals to negative 3 m upon 2. That is, you multiply that, you take that over. That is obviously going to give you negative 6 is equal to negative 3m. And surely from here you can see that m will also be 2. So you can also do that without actually having to do that, because again, you know what the y-intercept is, and you can simply do that. Would you get the same if you were to substitute the other point, y equals to mx plus 3? Our other point, remember, was the y-intercept. Our point is 0, 0,3. So if you take 0, 0,3, y is 3, and that is m times 0 plus 3. This is not really going to help us because now it makes the gradient to be naught. Can you see that? 0, 0,3, the x value, can't use this one, because if the x value is now 0, it's not really going to help us, because we now want to find what the gradient is, and anything times that 0 is going to be nothing but 0. So all this one confirms is just what the y-intercept is. When x is 0, that's where you get the y-intercept, which is something you can see from the diagram. But if you were to use this other particular point where you have an x value, okay, and whatever the y value is, irrespective here, as long as the x value is another value, you can definitely rearrange it and find the gradient. Okay, so that could be one method that you could use to find the gradient. Also study your diagrams to make sure that you do understand what they mean. Okay, now part 7. Okay, these are also questions you'll find in in your textbooks, and find them in your previous papers. They will come in handy. Of course, here you can make the denominator the same. X raised to the power 4, that 18 remain, and that 1 obviously needs to be multiplied by x squared, so that will be x squared on top there. And what you now have is, I have a common denominator, and obviously that's going to be 18 plus x squared equals to 4x raised to the power 4. If you have to get rid of that, so that's 4x raised to the power 4 minus x squared minus 18 is equal to 0. So hopefully you should see that this is a hidden quadratic, and if that is the case, you can say, okay, two numbers multiplied give you, let's see, you can do that, of course, if you want to. 72, okay, 4 times 8, 32, 72. The two numbers multiplied give you 72, and if you, that is the value of AC, and if you now look at the value of B to give you -1, so the only way would be if you have 9 times 8, and the -9 is the other value. So at the end of the day, you now know I have got 4. Of course, I can leave it like this, 4x raised to the power 4. Then I have minus 8x to the power 2. Sorry. So what we do is, we let's just see what happens here. Okay, so it's one of those things. Keep on pressing something, and we're gonna go back, and I'm just gonna open the document again. Don't worry about it, these things happen. It's been a while since I have been doing this videos using the software and whatnot, so sometimes there are glitches in the system, but we're gonna open it again and we're gonna continue. Remember, we were busy with that hidden quadratic. Okay, so that brings me back. So this was for 8x raised to the power of 2 minus 8x squared minus 9x squared minus 18. Okay, or you can also use that where you say x squared should be k, doesn't matter, and then you work from there. So basically here you're going to have a common thing would be 4 x squared. That will leave you with x squared minus 2 minus 2. Now, this one should be a positive 8 because you have a positive 8 over there. So plus 2. And here you have a negative 9, which is common, which is going to be x squared plus 2. So at the end of the day now, if I have to factor out, the common factor is x squared plus 2. So x squared plus 2 is a common factor, and 4x squared minus 9 is a common factor. Of course, you should now let each one equals to 0, but for this one it won't work because you'll have x squared plus 2 equals to 0. That will be x squared equals to negative 2. It's not going to help us much because you can't take the square root of a negative number. But 4x squared minus 9 equals to 0. This is the difference of two squares, or you can find a way that you can solve this. So here definitely we can find solutions. And the two solutions here would be, if you were to equate each one of these brackets to 0, you'll have 2x minus 3 if that equals to 0, or 2x plus 3 if that equals to 0. So the value of x would be positive and negative 3 over 2. These would be the solutions, and again you can go ahead and you will see that those solutions will definitely work out. So again, this is not the only way you can do this. Maybe you have a slightly different approach. As long as you get to the same solution, that's the only thing that matters. Right, now we get to question 8. This one says, find the range of values, again, plural. So you have here a quadratic inequality, and you're supposed to remember, when you're dealing with a quadratic inequality, you want to find the range of values of x for which this quadratic inequality will be less than. That now implies when it's less than. So if I was to sketch, that's a positive value, the value of a is greater than 0, it's 1, then this parabola will open up something like this. So my solutions must be below the x-axis. So which means my solutions to this to this quadratic would be below. And as you can see, whatever these critical values would be, it will be a range from the two extremes. I hope that makes sense. So what we need to do is we need to say for the x-intercepts, in order for us to find those critical values, we're going to say x squared minus 6x minus 7, let it equal to 0. Of course, this factorizes x minus 7x plus 1 equals to 0. You should be able to find that. So x equals to 7, or x equals to negative 1. So the critical value is negative 1 and positive 7. So our answers would be x is then going to be between 7 and negative 1. Also take note that the critical values are excluded. That means we are not going to have or equal to. Alright, so basically they're excluded here because of the condition of how our inequality was given to us originally. So those critical values will not be included. The inequality does is x is less than 7 or greater than negative 1. Good. Now let me come to that part that I was saying on how to do this question. So I'm introducing something to you. Remember we said you have to find the other coordinates of A. So we're going to say that 2x squared plus 5x, remember it was supposed to be plus 3. So just make sure that our equation, because now I've copied it over, is supposed to be plus 3. One of the ways you do this, obviously first you are going to identify different values. Obviously my value of b in my equation is 5 and my value of a is equal to 2. And we're going to use the concept that the sum of the roots That means whatever this -1 plus something here should equal to minus b over a. And let's see. So the sum of the roots, so I know one is -1. I don't know the other one. And minus b, so it's -5 upon 2. Alright, so one of the roots for a, the x value would be, well, this is nothing but -5 over 2. Add 1 to it. Okay, if you add 1, because that's a -1. Well, adding 1 is the same as adding 2 over 2, because that's another way. You can use a calculator, simply up to you. -5 over 2 plus 2 over 2. So that's going to be -3 over 2, of course. So that is going to be -3 over 2, which is what we had originally. So the coordinates of A would be -3 over 2, comma 0. Okay, if you have to go back to the video in order for you to be able to see, that's what we did there when we wanted to find that. Okay, so another thing, that's when you use the sum of the roots. You can use by that formula. Sum of the roots should equal to minus b over a. There's also one way we take the products of the roots. Now remember, our equation, let me just bring down our equation. Our equation was 2x squared plus 5x plus 3. So our equation was 2x squared plus 5x plus 3. That's what our equation was. So in this particular case, if we multiply the products of the roots, it should give us whatever the value of c over a is. So c we know is 3, and a we can see that a is equal to 2. Right, using this one, are we going to get the same answer? Let's see. So we know one root, which is here, -1, times the other root, I'm just going to say times x, the second part, or just x, and that's totally up to you, should equal to c, which is 3 over 2. And surely that negative is going to make that whole negative. So the second root, therefore, would be nothing but -3 over 2. Therefore, the value of a, or the coordinates of a, is -3 over 2, comma 0. So, same answer. You could have used that approach if you want to find one root given the other. That's what you can do. Will always be the case. Okay. So it's just something extra that I've added there. Remember from our original one here, of course, you had to use what you know, trying to find the other root, stuff like that, factorize and whatnot. But there is also that straightforward way where the sum of the roots should equal to minus b over a, and the product of the roots should be minus, okay, sum minus b over a, the sum of the roots, or the product of the roots. You multiply the product of the roots to give you c over a. Alright, it's just something extra that I've added for your convenience. See if you can use it in future, or try to do a few exercises, similar exercises, until it gets to you. But you're not going to get that one. It's not in your syllabus, but it's quite interesting to know. Right, so stand by for my third test that I'm going to upload, and this one involves the modulus, or the absolute value functions, as well as polynomials.